Autopan is an effect that creates the perception of a sound moving to different locations across the stereo field. One way to think about this effect as if we are using a panning potentiometer and twisting it to different locations during our signal. When it comes to writing our computer code, we can make use of the panning functions that we've looked at before. However, in this case, instead of using a single value that represents the constant position of the panning pot during our signal, we're going to synthesize an LFO signal that has the exact same length as our input signal. In this case, the amplitude of the LFO at each individual sample represents the position of our panning pot at the corresponding sample in our input signal. This LFO could be a sine wave, a square wave, or any other type of test signal. So first, let's take a look at, in our digital audio workstation, how we can create this type of effect. Then, we'll switch over to Matlab and look at writing our own computer code to create the Autopan. Here in my digital audio workstation, I'm going to demonstrate the concept of the Autopan effect. We'll start out with a mono input signal. It sounds like this. If we'd like, we can change the perceived spatial location of this signal by using the panning potentiometer to place it at different locations across the stereo field. For now, I'll pan it over to the left. If we'd like, on our timeline, we can even switch over and look at the panning position throughout our signal. So here, if I were to change it over and pan it to the right, position of this line is going to change. When I pan it all the way over to the right, that's a value of 100. When I pan it to the left, that's a value of minus 100. The concept of Autopan is that we like to have this panning potentiometer change throughout our signal. It's as if we or an assistant engineer is standing by and twisting this knob while our song is going on. The way that we can do this in our digital audio workstation is use automation. What I'm going to do here is go up and select the pencil tool. Specifically, pick this triangle. Now what I'm going to do is draw in the panning position throughout the signal. So we'll start here, draw it in. It's going to go back and forth during our signal. Now listen to what happens and watch the panning potentiometer over here while our signal is being played back. So this is the concept of the Autopan effect. Let's switch over to Matlab and see how we can recreate this by writing computer code. Now let's create the Autopan effect in Matlab using our own computer code. I'm going to modify a script that we created previously called panning functions. Right now the script is set up to take a mono input signal and create a stereo output signal by panning the signal to a single constant location across the stereo field that's based on this panning value variable. Spans a range from minus 100 to plus 100. We also have the script set up for different types of panning, from linear, square law, and sine law. Down here at the bottom, I've commented out the code that we could use to compare the different types of panning functions to each other. I've also rearranged the code so we have these commands where we actually create the output signal at a single location. So now it's just a matter of commenting or uncommenting the different types of panning that we like to use. So now I've got the script set up that we can work with square law panning. Next, let's look at and talk about what needs to be done so we can accomplish the Autopan effect. A lot of this is going to come down to how we create this pan value variable. Currently, it's a scalar, a single static number that doesn't change throughout our script. More importantly, throughout the signal, so that all samples in our signal are going to be panned to the same location. However, when we want to create the Autopan effect, we actually want to create a signal here, an LFO, so that the pan value changes throughout our entire input signal. So currently, I'm going to make a comment in here. So if pan value is a scalar, that is going to be constant or static panning. But what we like to do is create this variable so that it's going to be a signal, an LFO. So I'll make this one pan value. We're going to assign it something here. So if pan value is an array, now we can create the Autopan effect. There are many different ways that we could create this signal, but let's stick with conventional types of LFOs. In fact, let's use a sine function. So in this case, what we're going to do is create a sine wave that lasts the entire length of our signal. We're going to assign it to this variable that then we can use throughout the rest of our script. So here, type in sine. We'll use very similar kind of input that we've used before. 2 times pi times f times t. Now we need to create these variables if we're going to use them. So to begin with, we'll create f here. This is going to be a frequency in hertz. Say this is the frequency of the LFO in hertz. Now we're going to create t. T will be our time vector. This needs to last the entire length of our signal and have units of time. So here we'll put in an array starting with a time value of 0 up through the length of our input signal. Take off one sample on the end and then multiply by 1 divided by our sampling rate. So then we just need to transpose this like we've done many times before. So we're working with a column vector. Now we've got everything set up that we can create this sine wave. But currently, our sine wave spans a range from -1 to +1. It's as if our pan knob is just getting twisted back and forth right around its center position, from 1 to -1. It's not at all spanning the entire range. So if you want to create the full effect where our signal appears as though it's getting panned all the way over to the left and then all the way over to the right and back and forth, we need to increase the range of our sine wave. So in this case, we're going to multiply by 100. So now if you think about the range that this signal will take, pan value is going to be a sine wave that goes from 0 up to 100, back to 0, down to -100, and so on, and repeat that pattern. Now it's going to trickle through our rest of our code. So this pan value is going to be an array. We have to be careful of when we're going to use an array compared to a scalar number. So in this case, we can use pan value that will be an array divided by 200. That will automatically be element-wise division. We can assign the result of this to x. X, again, in this case, is going to be an array. It will not be an individual number. So now when we use x with a square root function, we have to make sure and think about, will the square root function handle an array? And yes, it will. It will create a new variable for us called right amplitude that will also be an array. And that will also be the same with the left amplitude. So what becomes a little bit tricky is when we go to use it here to create our output signal. In this case, left amplitude and right amplitude are arrays, and so is our signal. So we want to be careful here when we perform the multiplication. In this case, what we want to do is perform element-wise multiplication. This is going to be very similar to when we created the tremolo effect. In this case, it's a stereo tremolo effect where the amplitude on the left side increases while the amplitude on the right side decreases and vice versa. So now this will be able to have us be able to create the perception of our signal going from the left over to the right. So now what I'll do is run our script and we can listen back to the result. We've successfully created the Autopan effect. We can even go back through and modify some of these parameters. So instead of a frequency of 1, how about we do a frequency of 0.25? We'll really slow down the rate of our LFO. So now you can hear it. We've been able to create the Autopan effect. We even looked at several modifications that we can make to our code so that we can adjust common parameters that are typically used with Autopan.